Today lecture is about function of several variable, and we will find limit of function at a point specifically, and variables are more than one or two. So what is the meaning or how to find limit? Actually, I'm not going to the theory part of the limit of the several variable function. I am directly try to solve some problems and explaining you how many types and ways to find solution of some problems. So let us take one problem as fx comma y is given to us as x square minus y square divided by x square plus y square, and we need to evaluate limit at 0 0. Evaluate limiting value limit at 0 0. We can write this problem as limit x comma y is tending to point 0 0, and this is function of this structure x square minus y square divided by x square plus y square. If limit of this function exists, it means from every path which is going to point 0 0 is giving the same limiting value. If we are seeing two paths giving different limits, then we can say easily limit of this function or any function not exist. So we solve this problem. So first, actually we cannot find along all paths, so we will try to find along some particular paths. So you can observe in numerator part and denominator part, x square minus y square means powers of x and y is same in numerator and denominator. So if we put y equal to mx, then it will transform complete function in one variable, or I can say this function reduce in one variable. So limit as in transformation, if x tends to 0, then y tends to 0. So I can write a limit x tends to 0 only, and this can be written as x square minus m square x square divided by x square plus m square x square. From this you can take x square as a common from numerator and denominator, and left term will be free from x. So it can be written as limit x tends to 0, 1 minus m square divided by 1 plus m square. So limiting value of this one will be same because this expression is free from x, so no effect of x. For different values of m, we will get different value of this expression. So limit of this function at the point 0 0 doesn't exist. So this is good way of saying limit of this function is not existing. So if I find along the path x-axis or along x-axis, so if along x-axis, it means y equal to 0, and we need to reach at the point 0 0. So from this side and this side along x-axis, so we need to reach at the point 0 0 along x-axis. So I can write this expression as limit x tends to 0, because y equal to 0, so expression we have x square upon x square, and other part will be 0, so it will cancel out, and we have limit x tends to 0 of constant function. So limit is 1 along x-axis. Now try to find limit along y-axis. If we find along y-axis, it means x equal to 0 and y tends to 0 to reach at the point 0 0. So I can write limit y tends to 0, and the expression we have, it will be y square upon y square means this one cancel out and we will get -1 as a limit. So you can see here 1 and -1, these two are different, so limit of this function is not exist at 0 0. So we discussed two ways here to check limit of the function is not exist. Now consider another example. So function is given as, it is function of two variable xy upon x square plus y square, and we need to check limit at 0 0. So I can write limit x comma y tending to 0 0 of xy upon x square plus y square. So each term of denominator having power 2 and numerator is also, if we put y equal to x or y equal to 2x, or you can say y equal to mx, then this several variable function can be treated as single variable function, or it may be transformed in single variable. So I am using this one because sometimes it is convenient to use, or most of the problem like this can be easily solved by this transformation. So I can write limit x tending to 0, and I am replacing y with mx. So I can write mx square upon x square plus m square x square, and after removing x from numerator and denominator by taking common, so what we have, m upon 1 plus m square. For different values of m, we will get different value of this expression. It means the limit of the function at the point 0 0 doesn't exist. So this is along the curve which are y equal to mx types. If you particularly put y equal to x, then you can easily solve. So at reaching point 0 0 from along the path y equal to x, it means that limit x tending to 0, x square upon x square plus x square, and we have 1 upon 1 plus 1 means 1 upon 2. So along this path we have limit half. Along y equal to 2x, what we have, we will have limit x tending to 0, and it will be 2 x square upon x square plus 4 x square. After taking x square as a common, what we have 2 upon 5. So we can say that along different paths we are getting different limits. So limit of this function is not exist at the point 0 0. So you can solve this problem with the help of polar coordinates. If you transform, if you are seeing x square plus y square, either integration or sometimes in finding limit, so try to solve problem with the help of polar coordinates, because of sometimes the polar coordinates can make problem easy one. In polar coordinates, I can replace or use as a transformation, as the point is 0 0 0, so x coordinate is 0, so 0 plus r cos theta, or directly I can put x equal to r cos theta, and value of y will be 0 plus r sin theta. It means r cos theta and r sin theta are the respective transformation of x and y. So put this, what we have as a structure of the function in polar coordinates will be xy upon x square plus y square. After putting this, what we have, r cos theta into r sin theta upon r square. After cancel out r square from numerator and denominator, we have cos theta into sin theta. So function can be written in terms of theta or in polar coordinates. So along the path we fix the value of theta as pi by 4, and r tending to 0. If r tending to 0, it means we are reaching at the point 0 0 in the direction of theta equal to pi by 4. So I can write limit theta tending to pi by 4, because expression we get only in terms of theta. So theta is tending to pi by 4. You can choose theta any value, means pi by 2, pi by 4, or always try to put a value or choose value which make your calculation easy. So sin theta into cos theta, value of this at the point pi by 4 means sin pi by 4 into cos pi by 4 means half. And at the point pi by 2, when theta is going to pi by 2, we have sin pi by 2 into cos pi by 2. Value of cos pi by 2 is 0, so limiting value is 0. So we are getting different limits when we are reaching at the point 0 0 from two different paths, or in direction along theta pi by 4 when theta is pi by 2. So there are many ways to say limit of the function or several variable, how we solve or try to find limit exist or doesn't exist. But this way is not good to prove, or not good, or we cannot prove by this process if limit of this function is some value, because we have to check all paths, means all paths or all direction we are getting it. It is not necessary we are reaching at the point from straight path, it may be curve path. So in all direction we need to find limits, but it is not easy task. So proving limit of several variable function is some value, it is not convenient. So we need to have a way by which we can prove that a specific number is the limit of some function, and that will be the analytical process. And you know how I can extend, or you can extend limiting concept of epsilon, delta, and sequential criteria. There are two other ways, means we need to choose two sequences which are coming from domain and reaching at the point for which we have to check limit. So this is the lecture about function of several variable, and specifically how to find limits or check